So we've been talking a lot about properties of integrals and what we have to do now is actually do some calculations on how to find these integrals, and this table will give you an idea of the types of integrals that you just have to have on hand. So they are must know. You must remember these. So before you go on and do any more work, you need to memorize and just know these integrals. So they go a little bit like this. If you've got a function of x, what is the antiderivative? That is, f of x is going to be the integral with respect to x of f of x. All right, so this is the integral, or what we've been calling the antiderivative. Now I'm not going to put plus c, but I'll assume that you will know to put that if you're asked to find the indefinite integral. So if you've got a constant c, what have you got to differentiate to get c? Well, just cx. All right, so if maybe we do an example here, the integral of 3 with respect to x will be just equal to 3x. Okay, so that's the first one. So c is a constant. Next one is x to the power of n. Now we'll make a little proviso here that n is not equal to -1. There's a special rule for that one. And the integral of that, now one way to remember it is add a power, so x to the n plus 1. So you add 1 to that power and then you put it over that new power. So the way to remember that is add a power on the power. So the integral of x to the power of 5 with respect to x is equal to, add a power, x to the 6, and then you put it on that power. Okay, so don't forget we should be putting, if you were asked for the indefinite integral, you would put plus c, but we're assuming here that you may be doing the definite integral, so we'll just leave it as that. Now that's if n is unequal to -1. So if it is x to the -1, now another way to write that is 1 on x. So the integral of that will be ln x, natural log x. Now that one's a little bit out of the blue, because if you're thinking of that rule, when you add 1 to that, you get x to the power of 0, which is certainly not true. So it'll be ln x, and that's just a straightforward one. So don't forget x to -1 is another way to write that is 1 on x. This n value can be any other negative value other than -1. So this can be x to the power of -5 and you still add a power on the power. The only time you do it differently if n is equal to -1. The integral of cos x, we're not putting integral in it, so if this is f of x, the integral of cos x is equal to sine x, because when you find the derivative of sine you get cos. And if this is sine x, the integral of that will be negative cos x. Now in these cases here, x has to be in radians, not degrees, so you need to do the conversion. Exponential, the integral of e to the x, it's a strange one, it's just equal to e to the x. So when you integrate e to the x, you get e to the x. A couple of trigonometric functions, the integral of 1 over the square root of 1 minus 2x squared is equal to arc sine of x. Now arc sine x is sometimes written as sine to the minus 1 of x. Now, don't think that that is 1 on sine x. That's not 1 on sine x. Arc sine x is find the angle whose sine is x. So you can write it like that, or arc sine. The integral of 1 over 1 plus x squared will be equal to arctan of x. Once again, that's the way it's written on your calculator, tan to the minus 1x. That is the angle whose tan is x. And we've got two more down here. The integral of cosh x is sine x, and the integral of sine x is equal to cosh x. But different to cos and sine, we get negatives. The integral of cosh is sine, and the integral of sine is cosh. So this table, I would implore you to actually sit down and write it out, stick it up somewhere, test yourself numbers of times a day, just to make sure that you commit all of these to memory before you even start doing the tube questions. You should know all these and be able to apply them. So we're going to come back and do some examples, and to do those you should have these already committed to memory.